Welcome to the activity 8.3. This is out of our PS2 book. How much chemical energy is there? So this is a lab alternative. Maybe you're absent, maybe you couldn't do the lab for other reasons. So our learning target today is we're going to evaluate what influences the amount of chemical energy that is transformed into thermal energy. In other words, what are the factors? So for example, when we talked about kinetic energy, there's two factors, speed and mass. When we talked about gravitational energy, there's two factors that affect the amount of gravitational energy. The elevation from which something is dropped, in other words, its position, and its mass. The higher the elevation, the more GE it's going to have, as long as mass stays the same, that is. So the first thing I want you to do is open up your books to page 85. And at the very top it says prediction. What factors do you think will influence the amount of chemical energy being transformed during chemical reactions? For example, how could you make the temperature of the solution increase more? So go ahead and in that space, just in a sentence, or maybe you're just going to put a couple words down. What factors do you think influence the amount of chemical energy? All right, so if you're still going, you can pause the video, but we're going to move on. So the expectation for you is to analyze and evaluate the data that you collected. So what I'm going to do is I'm going to talk to you about what's going to be happening in this lab, and I'm going to give you some simulated data that's going to help you out. So if you remember from 8.1, what we did was we put copper chloride in a solution in water, and we took the temperature. There was no temperature change. But then we added 0.5 grams of aluminum foil, and there was a big temperature change. So we know just adding copper chloride to water does not cause a chemical reaction to occur. But once we introduced the aluminum foil, we did. And you might say, well, what's our evidence for that? How did we know? Well, the temperature rose, so that chemical energy was released as thermal energy. There was a vapor or a gas that was given off. If you felt the beaker was really hot, and you could also hear some crackling or, like sizzling noises coming out of the beaker. So when we look at different types of data, you can have quantitative data. That would have been the temperature change. But then you can also have qualitative data, that it felt hot, that you heard the sizzling, that you saw the gas, and you could even smell the gas that it gave off. So what we're going to do in 8.3 is we're going to manipulate the variables. We're going to change them. So instead of adding 0.5 grams of aluminum foil, we're going to add 0.8. Now your book will say 0.75, but our balances don't go out to the nearest hundredth place. They only go to the nearest tenth. So we're just going to round it up to 0.8 grams of aluminum foil. So what did you observe? So because you're not actually doing the activity, this is what you would have observed. The color of the solution changed. Aluminum dissolved in the solution and its color changed. New substances appeared, and the reading of the thermometer increased. In other words, you saw a lot of the same things and heard some of the same things when you put aluminum foil in 8.1. I could have added more here. You could have talked about hearing the sizzling noise. You could have talked about seeing the vapor or the gas that's coming up. So there's different things you could have put. So this is what I want you to put for your initial temperature change, 21.6 degrees Celsius. And for the temperature after the immersion of aluminum foil, this is 66.3 degrees Celsius. And that temperature change is 44.3 degrees Celsius. So you're going to use this data because you're not actually collecting the data in class. And you can use this data to finish up the conclusion and the follow-up questions later on. Now, in 8.3, we're doing a second experiment. So in the first experiment, we manipulated the mass. In 8.1, we had 0.5 grams. Now we change it to 0.8. In other words, what variable did we just change? If you're thinking mass, you're right. We changed the mass. So did the amount of mass affect the amount of change? So look back at 8.1. How much change in temperature did you have? Now look at 8.3. How much change in temperature did you have? Is there a difference? So now moving on to the next part. What we're going to do is you're going to put steel wool in it. You're going to put 0.5 grams. Now you're adding 0.5 grams of steel wool because that is what you had in 8.1. So we're going to compare apples to oranges in a sense because we're comparing two different items, but the mass is the same. So we're comparing aluminum foil to steel wool. So we're going to keep mass the same. So we're not looking at the amount of mass, we're looking at the type of material. So what would you have observed if you had put steel wool in there? Well, you might have had something like the color of the solution change, the steel wool color change, new substances appeared, and a reading of the thermometer increased a few degrees. Now look at this temperature change. So when I initially took the temperature, it was 20.8 degrees Celsius, and now look, it's only 25 degrees Celsius. Did it change? Yes, absolutely it changed. It changed 4.2 degrees. But that's quite a difference than when we added the aluminum foil. So the thing you have to think about is, does every substance have the same amount of chemical energy stored in it? Well, no. According to this, we could see that it doesn't. Now, of course, it might just be that it reacted differently with the copper chloride than the aluminum foil, but that's the way it is. You look at batteries, there's all kinds of different batteries out there. And, which batteries work better? Well, some work better in certain situations than others. So you really have to do you have to investigate the different types of batteries to see exactly what you want to use. But here we can see that different types of materials react differently. So what I want you to do on page 86 is look below table 2 and make sure you add this data into your table 2. I want you to finish up the conclusion and the follow-up question. The conclusion is, what factors determine the amount of chemical energy an object has? And then the follow-up, give an example of chemical energy in your daily life. Once you have finished that, make sure you ask questions if you have them of your teacher, and make sure you let your teacher know that you had completed the activity. Thanks.